we actually delve into Move, which is I know sort of what everyone wants to hear about today, I want to take a little bit of a step back and hear a little bit more about Mist and Labs, especially because when we talk about what we're building at Sui, I think we normally talk about two sort of big differentiators of Sui relative to other blockchains or other things that are happening in the Web3 space. One, of course, is Move, and we'll get to that. But the other is sort of Sui's data model and architecture. Can you just tell us a little bit about that so that everyone is sort of on the same page?
Yeah, absolutely. So the thing that's really different about Sui compared to other L1s is when we designed it, we started from scratch and we thought, like, what we really want here is sort of Web 2 style horizontal scalability. What that means is if I have a validator and I give them a one-box machine with one core, I get a certain amount of throughput and I can store a certain amount of data. If I give them more cores, I should be able to process more transactions. If I give them more machines, I should be able to process more transactions. If I have more disks, I can hold more data. And we basically don't want there to be some point where this stops becoming true or significantly degrades performance, like, oh, once we go to multi-machines, it's way slower, or we just can't do it. We really want to scale the way Web 2 services do by just adding more resources as you need them, and even doing so elastically. Like, if the traffic is spiky, you provision a bunch more machines for a little bit around Christmas, and then you bring it back down. So when we designed Sui, we really thought about, like, what do we need to do in order to achieve this goal? And the key thing there really is this new data model, where in conventional blockchains, you have this account-based data model where the state is basically a ledger. There are addresses, and then the addresses map to numbers that represent balances, or the data or bytes that represent NFTs. But if for something like, say, something like a coin, all of the balances live in the same smart contract. So all of the operations on that coin are going to hit the same smart contract and cause a contention point. And with Sui, we organize things very differently. We organize it around objects. The global state is organized as this set of objects. Objects all have globally unique IDs. They have built-in ownership information. An object knows I'm owned by an address, or I'm owned by another object, or I'm a shared object that can be interacted with by anyone, and there's some set of rules for defining that. And then these objects have types, types defined in Move. It might say, I'm a Sui coin, I'm a USDC coin, I'm a Bored Ape NFT, I'm an auction, I'm a DEX, each of these kinds of things. And then the type of the object gives you the rules for what operations are valid on that object and who's allowed to interact with it. And so this object-centric view makes it much easier to do a lot of different things that matter for scaling. So the most obvious one is parallel processing. The structure of a transaction in Sui is it operates not on accounts, but on objects. It takes some set of input objects. You'll say, hey, I'm going to interact with this DEX. I'm going to take this coin as input. Maybe I'm using this NFT. And then the transaction is allowed to read and write and transfer those objects, but not other objects. And then the effects of the transaction are also captured in terms of objects. You have mutations to the input objects. You might create new objects. You might destroy some of the inputs. And what that does is, when you look at a transaction, you can see what it's going to do in advance because you know what objects it's allowed to touch. And so it's easy to tell, these touch disjoint objects. I can throw these to different threads. These touch the same object, so they have to be sequenced with respect to each other. It also makes it easier to scale your storage because you know up front what you're going to need to read or write, and you can fetch that in a big batch, even if it lives on a different machine or across the world in a different data center, although I don't think a validator would organize that way. Mm-hmm. And so this data model just makes it it makes dependencies explicit, and it makes it a lot easier to use sort of conventional scaling techniques, which is very, very different from these other data models where you basically put all objects in a common point of contention. And so that gives us a lot of our scaling. It lets us scale execution. It lets us scale consensus in some ways as well, because we can tell, is this an object that needs to go through consensus because its accesses need to be sequenced with respect to other objects, or can it use this faster path, Byzantine consistent broadcast, which has much lower latency? So these are the higher order bits of what Sui is doing differently. Really, this focus on objects is just a big hammer that we use for a lot of different things, for scalability, for usability, and other things we're still discovering.
Yeah, that's super useful. And I think like the parallel to the obsession with bugs before now is sort of object. And I think like you're going to talk a little bit more about this later, which is the version of Move that runs on Sui is also a special version of Move that has been optimized to work hand in hand with sort of this data model. I mean, I want to hear much more. I think everyone wants to hear more about that. But before we get there, why don't we actually dive into the basics? Like, what is Move? Can you tell us, like, high level, what is special about Move? I think, when we talk about Move with developers, there's sort of two reactions. People that come more from deep from the Web3 world and are familiar with other types of programming languages, things like Solidity, they will ask, well, what is special about Move? And people that are perhaps not so deep into Web3 will just ask, like, why do we even need another programming language? So can you give us a little bit more color on sort of what Move is and what are its strengths?
Yeah, absolutely. I mean, these are great questions, and these are always the questions that you should ask, because for any programming language, the most valuable asset is its community and sort of the existing tooling, the existing ecosystem. So if someone tells you they want to create a new language, you should be very skeptical a priori, and there has to be a really strong motivation for it. So for Move, like, I think I'll tackle this question first about why do you need a new language? Indeed, like, if it were possible to use Rust or use WASM or use the JVM or the CLR or some established language with a big community and big libraries, I think that would be the preferable thing to do. And this is actually what we looked into doing first. That doesn't make sense, or we think it doesn't make sense for a few reasons. Like, there are some properties that smart contract languages need that in a normal language you generally don't have. So you need determinism. That's a very important part of doing anything with the state machine replication paradigm that smart contracts are using. If two validators might get different results, even when they execute the same code, the consensus isn't going to work at all. And that doesn't seem like a tricky requirement, but most conventional languages aren't deterministic. You'll have constructs like iterating over a hash table, and that's going to depend on memory addresses that'll be different in each execution. And so it's not deterministic. And you can try to sort of change the language to cut that out, but then you end up cutting out a lot of the libraries and tooling and stuff that relies on those features. And then also you need metering, this gas metering feature. That's something that is super important for smart contracts so that you don't use infinite resources, but in a conventional language, you don't have that, and you can't use timing, you can't use walk lock time for this because, again, it won't be deterministic. And then sort of more conceptually than that, smart contracts are a super specialized domain. You're not going to write a compiler, you're probably not going to write a compiler or a distributed system or sort of like a web application in a smart contract language. You do a very restricted set of things. You define the shape of assets, you define the rules for reading and writing those assets and transferring them, and then you check access control policies, and that's basically it. So if you start with a general purpose language, it's going to have a lot of features and abstractions that you don't need, and it's also going to be missing things that are really specific to a smart contract programmer. So that was sort of our reasoning for not using a general purpose language, although we very much looked into that. You sort of get, if you try, you sort of get this chimera of, let me restrict the existing language to take out the stuff you don't need, like non-determinism, and then I'll try to add on metering and add on assets, and you end up with something that's very complicated and sort of takes away a lot of the advantages of the initial language. And then for like Solidity or folks coming from other smart contract languages, I have very strong opinions here, and I hope they don't rub folks the wrong way, but I mean, what I would basically say is that smart contract security is an existential threat to broader Web3 adoption. Like, you look at the smart contract developers there are today, they're extremely qualified people, they really understand the underlying blockchains, they're very security conscious, they take their responsibilities very seriously. And yet the result of their efforts is still this world where, you know, multi-million dollar, and when I say multi, I mean like hundreds of $1 million hacks are sort of a very common occurrence, like weekly or monthly. I think there's no reason to expect that this is going to get better as we grow the pool of developers. Like, future folks will be more product focused. They won't want to learn the depths of the blockchain or learn about security. And so I think the status quo of security won't get better, it'll get worse. And so I think that'll either lead to a place where Web3 just can't grow very much because there's no sustainable or safe way to grow the developer pool, or we need to really improve the underlying languages and tooling with safety in mind. And so that's really what Move is doing. When we designed it, we looked at the EVM, we looked at other smart contract languages. We did what I did for many years, like looked at programs that had bugs and tried to understand where did these bugs come from, what led people to create them. If we were going to redesign the language differently to prevent these or make them harder to write, then how would we do it? And so we started with that in Move and sprinkled in a lot of techniques from elsewhere in programming languages. This notion of linear types that's been, or linear logic that's been used to represent money or memory resources for a long time, like we baked that in very deeply to Move so that there's abstractions for programming with money. You can define an object type and you can say, I want this thing to not be droppable on the floor without explicit instruction. I don't want this thing to be copyable because that wouldn't be appropriate for money. I want to have really restricted creation for this, and I want to have strong isolation from other programs. So we take these sort of security principles and like nice abstractions for programming with money, and we put them there, but put them there in a flexible way so that we don't have a native asset defined in Move. We have building blocks that lets programmers create whatever kind of native assets they want. So that's really the foundation of Move. Is it's this programming language that targets this very domain-specific setting of smart contracts. It tries to provide the right abstractions for developers to write the kind of code they need to write, and then it has safety as a first-class principle. It doesn't have dynamic behavior or code injection, which leads to a lot of, or reentrancy, which leads to a lot of these security issues elsewhere, and then it has really strong isolation features that are given to you at the type system level.
Okay, so that's super useful because, you know, it seems like there were a lot of trade-offs in the design space when you were figuring out how to do Move. But if you do believe in a future in which, say, the financial system becomes very big or ports over to Web3, you really need to optimize on safety and security front because the worst thing can happen, as you say, is when people lose their value or there are hacks or these type of things. So that was a little bit abstract, but I know you came up with a cool example that can help people understand a little bit better the power of Move. Okay, there we go. And I know we titled it "What You See Is What You Get," and I think there we went for the goal of saying, it's very simple the way to write it, but also you don't need to audit and it for hours and debug it for hours because the code sort of does what it's supposed to do. But I know there's another layer to that, which is actually the power is what you don't see. So I don't know, can you run us through this example and tell us like what are those two layers? What you see is what you get, but also what you don't see is what's the power of Move. What does that mean?
Yeah, exactly. So this code here is basically defining a stable coin. This is like our equivalent of using our equivalent of ERC20, which is this so-called coin module. And you see this import at the top of the code that says use sui : coin. So this coin module is the part you don't see. So it's like ERC20, but instead of being an interface, this actually has concrete implementations of all of the common coin operations that you shouldn't need to customize. So like transfers work the same way for all coins. Splitting and joining coins work the same way for all coins. But then of course for something like minting and deciding what the supply of the coin is or burning, that needs to be customizable. And so the way we express that is that there's this treasury cap type that it's what we call a capability. It's an object that gives the owner of this object permissions to do certain things. And so if you have the treasury cap, you're allowed to mint coins and you're allowed to burn them. And so with this stablecoin, what we're trying to do, it has to fit in a slide. So it's a very simple example. We just want a stablecoin at the max supply. And so the way we do that, if you look at this init function, this is a module initializer that runs when you publish this stablecoin module. We call coin create currency, which is delegating to this nice underlying coin module that provides all this functionality. We define a new type and ticker symbol for our coin. That's this STBL part. And then we pass this witness, which is like, making sure we're the only ones that can register STBL. Someone else can't do that. Then we get back from the coin module this treasury cap. We then lock the treasury cap in another object type that has the max supply. And then this transfer part is giving the admin cap to the sender of the transaction. And then we're showing the mint logic, which is what actually enforces the total supply. What we do is we take the admin cap as input, and here we take a mutable reference to it. And so what that means is I'm not giving the mint function the admin cap. I'm saying, hey, mint function, you can look at the admin cap for a little bit. You can read it. You can write it. But at the end, it's going to go back to me or to its owner, in this case, to the admin address. Then we specify the amount we want to mint, and then the recipient who's going to get it. And then this TX context thing is an object that tells you information about the current transaction, like it lets you create new objects and what's the current epoch and all this sort of stuff. And then this assert statement here is just enforcing the max cap. We look at how much have we minted so far, make sure that we're not minting too much, and then we throw an exception if so. And then we just delegate to the nice logic of this underlying mint function. We mint and then we transfer to the recipient, and that's all we have to do. And so this is a very simple example, but if you wanted to implement a collateralized stablecoin, you can imagine that inside admin cap, you just put the reserve that has the different coins that you have in there. If you wanted something with unlimited minting, you take away the max supply. If you wanted something with a deny list on who's allowed to be minted to, you can put that in the admin cap, and all of these sorts of things. You get all the flexibility to define the policy you want for your asset while also inheriting the safety that the coin module gives you. And so it's just this nice combination of like safety in the language, safety in the library, but then still having all the flexibility you need to implement rich use cases.
Yeah, that makes sense. I mean, maybe to speak a little bit about me and sort of what my reactions are, I'm an economist, I'm not really a developer, but even I can find this sort of somewhat understandable. And I think that is sort of one of the powers of Move, because what you sort of see in the world right now is other programming languages like Solidity are just so complex, and you need to really have a big degree of expertise to use it, which sort of makes it very inaccessible for new programmers or new developers that may have new ideas, but find it very hard to dive into a language that has so many challenges and also that can break if you're not super, super careful. And I think one of the reasons why we're all here obviously super excited about Web3, but the truth of the matter is that in many ways, Web3 has not delivered in terms of the use cases for broad adoption, especially for people, ordinary folks in emerging markets who may not have a lot of expertise in programming languages or computer science or any of these things, engineering, but do have a lot of ideas, right? Like, people all over the world experience their lives and they have a lot of innovations and they see the gaps in the real lives that can be addressed by things like Web3. But if it's very hard for them to go and prototype those and to access a language in which they can bring those ideas to life, ultimately there's a huge gate or a wall that will maintain them away from Web3. And so it kind of feels like as we get these more flexible, safe, friendly programming languages, it becomes much more accessible. We'll see a wave of product differentiation and innovation in which people all over the world will feel comfortable about building these type of smart contracts and maybe potentially finally delivering that killer Web3 application that might not be born here in Silicon Valley, but maybe in other parts of the world. I don't know if you have any views on that.
Yeah, absolutely. I mean, I think that's really the way I think about it too, and sort of gets back to this point earlier about the security being, and smart contract security being an existential barrier to growth. I think this is really all about improving accessibility of the smart contract programming experience. If it's a specialist task, then programmable money is sort of a specialist thing, and the gates aren't wide open. But if it's something folks can do safely in their dorm room and not have to pay for an audit or go through this protracted process or be really afraid about, that just really changes the game and opens up opportunities to a lot more. Alonzo, I've been talking a lot and gone pretty deep into Move, but I'd like to hear more about your background. I know you have a unique perspective as a trained economist and then someone who's also worked a lot on the product side. Both, I want to hear particularly about your history in Libra, where you worked on Move, but also Move is one part of the original Libra story where we want to provide broader financial inclusion and accessibility, and smart contract safety is one part of that, but just one small piece. So just to hear about the background and your journey through Libra and then to Miston.
Okay. I thought we were going to talk about Move today, not about me, but yeah, I'm totally happy to do it. I mean, as I said, I'm an economist. I used to be an academic for a very long time. I used to work on international trade and supply chains, which actually have a lot of interesting applications in the Web3 world. Things like tracking input, escrow models, like trade finance. I think blockchain has a lot of things that can deliver there. But anyways, at some point I decided to do something that was a little bit more hands-on. Academia is very cool, but you're sort of like a spectator of the world, whereas in startups and the type of stuff we do, you're really building products that hopefully will actually have a direct impact on consumers and people all over the world. So anyways, a few years ago, I joined Facebook, where we met, and we were all working on the Libra project, which was later called DM. And we initially worked at a part of Facebook called Calibra that was later called Novi. And it's very complicated to remember what was what. But anyways, I was on the team that was designing sort of the economic incentives of the Libra blockchain and the design of the Libra stablecoin. And so in many ways, sort of this conversation is very close to my heart because we're a conference by Circle, who is one of the issuers the issuer of USDC, which is one of the most robust stablecoins out there. It uses probably the safest model, which is backing the tokens fully in off-chain assets, dollar and dollar-like assets when we're talking about USDC. And Libra was really going to go along those designs. And I think that's really important because when you think about stablecoins, they really are sort of the foundation layer of the on-chain financial system. They have a lot of important applications like digital payments, cross-border payments, remittances, but they're also sort of the ultimate source of liquidity in the DeFi ecosystem. And if that foundational layer breaks just a little bit, the whole sort of castle falls down. And that can break in many ways, right? Like one is if it's the economic design is not well made and the token loses its peg. But another one is also like the smart contract in which you're issuing the coin is wrong, which is again, we go back to this question of why it's so important to have something like Move. And you see this all the time in sort of the financial system. If you're sort of been tracking what's happening in the United Kingdom this week, there's a ton of volatility because basically the yields on sort of their treasury bonds increased by a few percentage points. And because everyone in those countries or in the financial system thinks of like sovereign debt as it were almost very similar to fiat, when those prices move a little bit, everything can sort of fall down. And so the analogy here is if you have a stable coin that loses its peg just by a little bit, all that stuff that's built on top, that financial system, be it trading, derivatives, deep liquidity, market making, or even things for regular folks like credit, digital payments, and other stuff can break down. And so I think we go back to this question of like, why are we here? We're talking about Move. Move is very important for safety. We come from the Libra world, which was all about financial inclusion and building these tokens and this ecosystem to really unleash innovation in a very safe way. And sort of, I think we're both here because we care about that. We're trying to build Sui into an ecosystem in which, hopefully all of you get excited and start building applications, both for digital finance, but also, for the creator economy, for gaming, for all sorts of applications that we haven't thought about. And hopefully Move is sort of a very simple on-ramp towards that innovation. But since you sort of mentioned back the Libra past, I think, not many people have heard, like, I think now we have some idea of like what Move is, what is its strengths, but as the original creator of Move, what does that even mean? Like, how were those early days when you were sitting at, I suppose, Menlo Park and thinking about, like, we need a new programming language, this is where we start? Like, how did that go? What's that story?
Yeah, that was a very interesting journey, and I'm happy to tell the story because I don't know, it's just a time I look on my life I look on very fondly. Where when Libra started at Facebook, it was this top secret project to build a blockchain-powered global payments network. It was a super ambitious thing, and secret projects aren't a thing at Facebook. Almost everything is public. I can really only think of one other one besides this. But in the early stages, they were just like, okay, let's look at the technical areas that we think are relevant for this project and just pull in experts from across the company. So they found really great distributed systems folks, cryptographers, payments folks, databases folks. And then for me, they were like, okay, there's this smart contracts thing. It seems important. Like, we want programmable money. Like, figure it out. And it was a very broad mandate. They didn't say build a language or like use the EVM. They're like, just figure out what to do and like how you have the time to do it. So we, as I mentioned before, like we looked at using existing language and came to understand really like what it means to be a smart contract language, what the basic table stakes requirements are, like this determinism thing, like metering, and then what's nice to have, like being asset-centric, like Move is. And so we considered a lot of these different languages to adapt. We looked a lot at WASM, we looked a lot at the JVM, and just thought about this, extending them and tweaking them, and saw that it wouldn't work. And then we dug really deep into the EVM, both looking at code to sort of do the thing I do of looking at bugs and understanding what goes wrong, and then seeing like, can this be fixed in some higher level? Can we write a source language that's different than Solidity and eliminate bugs there? Or can we write static analysis tools on top of the EVM that will make some of the stuff go away? And after considering both those options and rejecting and sort of seeing where we thought it would go, that's when we decided to go in the direction of building our own language. Our thinking was, the smart contract space is very nascent. Safety is very important. It's very different from conventional programming environments. Like, this is a case where it's really worthwhile to, like, if this is going to be a big and important space, it needs its own JavaScript, its own WASM. You need a language that's specially tailored to this domain, and then it has to have these built-in safety guarantees and what's there. So we started off in a very interesting way of, we just had a syntax that didn't work. We didn't have a compiler interpreter. We would just like write programs and like, say what they should mean and try to figure things out. And you get these really fundamental questions of like, you write let x equals y, and it's like, what does the y part of that mean? Am I copying the y value? Am I creating a new reference to the y value and putting it there? Am I moving the y value from one point to another? And like, really, that was the breakthrough and like considering these basic things about assignment that led to the Move idea of, we really have these different modes for assignment and parameter passing, and it's very different whether you're passing around a reference versus passing around a value, and whether you're copying something versus moving it. And you want to give the programmer a lot of flexibility in deciding, is my type copyable? Is it movable? Under what conditions? Am I allowed to drop it on the floor without an explicit destructor, and all of that sort of stuff. So it was hard to convince folks that we should build a new language. I think the engineering leadership was justifiably skeptical. If an engineer comes to you and says you need to build a new programming language, you should tell them no, or at least ask for really, really good reasoning. And so there's lots of folks who wanted to use the EVM or even to use Bitcoin script back then. And so we had to like fight a hard battle to say, hey, this is a big undertaking, but we think it's worth it. But in the end, like, a ton of credit to the Libra Novi DM leadership. Calibra, yeah. They were extremely supportive. Like once they got the motivation, and I think they really gave this project the investment it needed to go forward. So yeah, I still smile when I think about that time, and I really remember that when we launched Libra and like the Move ideas first came out, just people's reaction to them, like, oh, like this looks interesting. This looks like what you want from smart contracts. It was really gratifying to see that.
So that's really interesting. Can you tell us a little bit about, obviously a programming language, like most of the things that, in the software world, it's not like they're ever finished. They're always live. You create new things, you update it, it grows, it adapts, whatever. How long did it take to go from like that 0 to 1 in the sense that Move was finally ready to be used for stuff? And second, sort of where are we right now? It seems like we're starting to get a relatively strong Move community, not only in SUI and other places. And what are sort of the next step in order, because I've heard you said before, we wanted to make sure that Move is the JavaScript of Web3. What would be required to get there?
Yeah, no, great set of questions. So we started working on, I started working on Move in, I think, April 2018. And I think we had the first running Move program probably around September of that year. Back then, the code name for the language was Tulip. That was wisely rejected by the DM leadership, and we moved toward the Move name instead. And then, since then, I think we had the source language came out in late 2019, and then we had all the DM code written and working in sort of late 2019, early 2020. And the journey for Move since then, I think going forward, is really trying to be as platform agnostic as possible. I think this is one of the key aspects of Move design compared to, say, the EVM, where if you look at the EVM, it overfits to a lot of the design decisions that Ethereum has made, to the account structure that it uses, to the block structure it uses, to the cryptography that it uses, and to the data model that it uses. And so if you're trying to build another EVM-based blockchain, you're going to end up inheriting a lot of those decisions, some of which are good ones, and some of which are things that make the blockchain harder to scale or make it harder to be safe. So with Move, one of our key design principles is it's an embedded language where there's a small core language that's totally blockchain agnostic. It doesn't have accounts, it doesn't even have coins. It's just a programming language that has sort of wacky features for programming with scarcity or preventing things from being copied. And then it has hooks for extending to be used in the context of a particular blockchain. You can use your own transaction format, specify your own account or data model, decide what cryptography or addresses you want to use. And so that allows you to take Move, use the Move toolchain, use existing libraries, use verification tools like the Move Prover, and just take that expertise and use it across any blockchains, not just DM back then. But now there's at least 4 Move-based blockchains. There's the original DM, there's SUI, there's Aptos, there's Starcoin, there's OL. All of these are very different in the way the blockchain works under the hood. None of them use the same transaction format or the same consensus. They do a lot of things differently, but yet they're all using the common Move code. And then there's lots of existing platforms that have expressed enthusiasm for incorporating Move as a second language, like Solana is doing a big exploration into this now. And I expect new blockchains in the future, when they're thinking about smart contracts, are going to take a hard look at Move because of the flexibility that it gives them and the excitement from a developer's perspective. So this is really one of the key things. We call it being platform agnostic. This is really important for a language. If the status quo today is you have one new programming language per blockchain, you can't really decide what language you want based on what you like. You're really betting on the underlying blockchain platform. Whereas with Move, you don't have to say, I'm a developer for this blockchain or that blockchain. You can be a Move developer, and your skills will largely be portable across a number of prominent blockchains today, and also a lot of other ones in the future.
Yeah, I would like us to go now into what's special about SUI's version of Move, but I think that's sort of an interesting paradox. There's a lot of these conversations going out in the Web3 world about, is the future multi-chain, or is there going to be one chain to rule them all? I think, when I think about it as an economist, going back to Adam Smith and the idea of specialization, that's probably important. It's very hard for me to think about a future in which you don't have some chains that are perhaps optimized for speed, and others are optimized for safety, and others maybe are more decentralized. Others are perhaps more programmable in the sense you will have a very rich ecosystem of different blockchains and perhaps even other types of infrastructure that serve different purposes or different use cases, but they have really good ways, hopefully, of communicating either with bridges or other types of cross-chain communication protocols. But what's interesting about what you're saying is that even though we can have that ecosystem of many different blockchains, it is still useful for the programming language that's used on top of them to be somewhat similar, so that you can have that developer community that can richly move across them. Because one of the probably richest and most important things in programming languages is to have that big, broad community who can sort of know the language, improve it, work on it, create sort of all these websites where you can get help and when you run into problems. But that said, SUI's version of Move is a little bit special, as you said. What is special about SUI Move, and sort of what are its main differences, and how is it optimized for the SUI blockchain?
Yeah, so with Move, it grew alongside DM, and we made a lot of decisions in the way we embedded into DM that were specific to what DM was trying to do. So DM was somewhat of a lockdown platform. We didn't want, in DM, account creation couldn't be generic. There were rules about that. Not all accounts could receive all currency types because there were capital controls you had to enforce. And then there were things like on-chain compliance that had to be built in very strictly. And so that style of embedding is something that made a lot of sense for DM, but doesn't make as much sense at all if you're trying to build an open smart contracting platform. Like, one particular pain point is if you define a new asset and you want to send it to somebody, they had to opt in to receive it first. You have to say, hey, I'm going to first create an account. That's one step. Then I'm going to create a special holder for, say, for Doge, and then once you've created that special holder, I can send you Doge, but I can't do it after. I can't do it until you've undertaken those 2 steps. And so we thought it was very important to eliminate that in Sui. And so with objects, any object can be transferred to any address without explicit creation or opting in beforehand. And so that just makes it much easier for objects to flow across addresses and be used freely as they are in other blockchains, but not in the original Move style. Another big thing is the ability to parallelize your transactions. We talked about this a little bit earlier with the Sui data model, but really we designed the Sui data model and this Sui Move hand in hand so that Move is object-oriented and asset-oriented inside, and then the transactions are asset-oriented on the outside. So we take away a lot of boilerplate that existed in the original DM-style Move. If in the original DM-style Move, if you were going to use an object, you pass in some ID for the object, and then you have to go dig it out of a hash table or out of an account, and then play with it, and then put it back. And in Sui, you write your entry point that gets called from a transaction, and you specify the object right there. And then it's the Sui runtime's job to look at the object ID that comes into a transaction, look up the ownership information for the object, make sure that the sender of the transaction actually has the permission to use it, and then you just go and write the interesting part of the code. So if you look at the same code in this DM-style Move and in Sui Move, the Sui Move code ends up being a lot shorter, and there are fewer opportunities to make mistakes because you can't forget those authentication checks as a user. The runtime takes care of them for you. And then the final thing is, the DM was designed before NFTs became super prominent, and so we focused a lot on purely the financial use cases, but and on strong typing. But it was very hard to do something like, I want to have a map that has a bunch of different kind of objects, or I'm defining a hero character, and they're going to have an open inventory where first they have a shield and a sword, but someone comes along and creates boots later, and I should be able to add them, even if the original hero creator didn't anticipate that. So Sui has really good support for having heterogeneous object associations and heterogeneous collections that let you have this sort of mix of nice static safe stuff, but then also extensibility in ways that the creator allows, but with a lot of flexibility for folks who are adding on these accessories to design them in ways that are rich and interesting. So there's been I think folks who have used Sui Move have been really excited about it. We have some folks who used to use the old DM style Move and now use Sui Move and really like a lot of the aspects of it. And we've learned a lot from the experience of embedding DM style Move and then specializing it to Sui. And I talked a lot about Move being cross-platform and it will be used in many places, but of course, we also think Sui Move is the best instantiation out there. I'm really excited for folks to try it. It's always a tension for me. I wear my Miston CTO hat, but then as someone working in the Move community, I have to wear a different hat in promoting Move and just always have to think carefully about each of those.
Yeah, that's important. I guess since we're almost out of time, a couple of points I think you've made today is Move was really thought of from the ground up to make sure that it was really well designed to support these type of applications, make it very accessible, being very safe, optimizing for security. And so the next question is, I want to sort of finish with 2 questions. The first one is just pretty simple. Where can people go learn more about Move? How can they get involved in the community? How can they start building? What are the resources that exist for that?
Yeah, so I would start with docs.sui.io. That'll point you to all of our resources about Sui Move. It'll have a link to our Discord where there's a lot of active discussion around Move generically and about Sui Move. There's also, there's 2 books on Move. Those will be linked from the docs as well. There's examples.sui.io, which talks a lot about Move design patterns and specifically about design patterns that are Sui specific and useful in Sui. And then in the Sui repo, there's a big list of examples where you can see example NFTs, DeFi code, minting coins, stuff like escrows, all the auctions, all the classic smart contract stuff so that you can see how to do that in Sui Move and sort of compare it side by side with your favorite smart contract language. There's also, under the Miston Labs GitHub repo, this awesome Move aggregator of Move-based content that has Move blog posts and examples and stuff from all across the Move community, both the Sui chain and other places.
Cool. And I mean, those are all, what was the website? docs.sui.io, right?
That's right, yeah.
You can find out, there's a whole bunch of resources there if you're curious, and I hope you guys are after this talk. So to finish up, what is something that you're particularly excited about, both for Sui, Move, the overall Web3 ecosystem? What's something that, when you go to work, it really sort of helps you push into those long hours and remain motivated?
Yeah, I mean, I think Web3 is all about growing the pie, and the key things for growing the pie are having these new fundamental building blocks. Like USDC, the Circle, the sponsor of this conference, is a key one, because this is a cross-chain, safe asset, stable asset, and that's a key building block on Web3 that everyone can use. Move, if we succeed in our mission, is like this too, where it is the safe cross-chain building block that is going to broaden the pie for smart contract developers. That's just going to be like the industry standard for what folks use and how they write code that interacts with assets and that defines safe smart contracts. And then Sui, in a similar vein, we're really trying to, with this focus on horizontal scalability, we're trying to really crack a different level of low fees and of being able to scale throughput and storage. It's going to unlock new use cases that are prohibitively expensive or prohibitively difficult to do elsewhere. So that's what gets me excited, is really the more you can expand Web3 with these generic capabilities that can be used broadly, the more potential is there to bring new folks into the space and to implement these new use cases. So I go to work very excited every day.
Yeah, that's very cool. I mean, probably a lot of people that are in the Web3 space have similar thoughts to your own, and having, for example, Circle support this conference and issue such an important foundation for the financial layer that's going to exist in Web3, and having Move be bootstrapped by a strong developer community that can create something safe and accessible for everyone to program on. And other companies also creating an infrastructure that can support all these applications is really important. So somehow we actually managed to end up right on time, which is great. I hope you all enjoyed this conversation. Sam and I will be here for a few more minutes, so if you have any questions or thoughts, please do come up and ask them, especially Sam. He has all the answers on Move. But yeah, I hope you enjoyed it, and do reach out and please become part of the Sui community. That's it. Thank you.